Multiplying polynomials. With this lesson, you are going to find numerous ways to multiply polynomials, and one way to multiply polynomials is by using the distributive property. So I have an example here of how you can use the distributive property to multiply polynomials. With more than two terms, you can use the distributive property several times, and an example is provided below. So if you look at this, I have 5x and then in the parentheses 2x squared plus 10x minus 6. Notice how they distributed that 5x to each situation inside the parentheses for the first set. Then plus the 3, then inside the parentheses 2x squared plus 10x minus 6. And you distribute the 3 to each situation inside as well. So what this would become is 5x times 2x squared would be 10x to the third. Then we would have plus 50x squared minus 30x. That would be the first set. Then the second set here we would have plus our 6x squared. 3 times 10 is 30, so plus 30x. Then 3 times negative 6 is 18, so minus 18. Another way you can multiply polynomials is by using what's called the rectangle model, and that's when you have more than two terms. So we had 5x plus 3, and then 2x squared plus 10x minus 6. So notice they use the rectangle model by putting the three terms for the top going down the rows, or the columns, I'm sorry, and then they have 5x plus 3. So what they did is they multiplied each term and then put the answer inside the box. So 5x times 2x squared gives me my 10x to the third power. 5x times 10x would give me my 50x squared. 5x times negative 6 is negative 30x. 3 times 2x squared is that 6x squared. 3 times 10 is 30x. 3 times negative 6 is negative 18. So then you would find the product, and then you'd add all the terms inside the rectangle by combining your like terms. So then we'd combine like terms and simplify if that's necessary. And so my final answer for this would be 10x to the third power plus 56x squared minus 18. Another method to multiply polynomials is by just using the standard method, the vertical method. And this method is used when multiplying whole numbers. So you can use this when multiplying whole numbers. So here we have an example of 2x squared plus 10x minus 6 times 5x plus 3. So notice they multiplied 3 times negative 6 is negative 18. 3 times 10x is 30x. 3 times 2x squared is 6x squared. Then we bring down our 0 here. So we have 5x times negative 6 is negative 30x. 5x times 10x is 50x squared. 5x times 2x squared is 10x to the third power. Then we add that all up, and we would get the same answer once we simplify. Of 10x to the third plus 56x squared plus negative 18. One of the other methods is called the FOIL method, and what you do here is when you are given two binomials, you can use the FOIL method. So what you're going to do is multiply the first terms, that's the f, so the first terms of the beginning of each parentheses, so that would be x times x. Then you multiply the outer terms, so that would be the o, x, and 2. X times 2 is 2x. You then would multiply the inner terms, the 3 and the x. 3 times x is 3x. And then you'd multiply the last terms, 3 times 2, which is 6. So we have here x squared plus 2x plus 3x plus 6. You would combine the like terms to get x squared plus 5x plus 6, and that would be your answer using the FOIL method. So let's look at multiplying some polynomials here using these different methods that I just showed you. hopefully in your notes you wrote down each of those methods. I do want you writing this down or physically typing it, not copying and pasting things into your notes, please. So looking at the first multiplication problem, we have 3x to the third power times 6x squared. So what we're going to do is I highlighted the values, the constants, and then we have x to the third x squared. So what we do is we multiply 3, think of this as the distributive property in y. 3 times 6 is 18. X to the third times x squared, we would add those exponents to get 5. So what we get here is 18x to the fifth, and that would be my final answer for A. Let's look at B. We have 2r squared times t times 5t to the third power. So we can multiply 2 times 5, which gives me 10. We would keep r to the second because there is no other r variable here. We do have t to the first and t to the third power. So we can add the exponents of the t's to get t to the fourth. So what I'd have here is 10r squared t to the fourth, and let's see if that's what we get. So again, I highlighted like terms. I'm going to put them in order here, and this is what we get, the 10r squared times t to the fourth. Here we have another situation where we're multiplying this. We're going to be using the distributive property. We're going to multiply 2 in the parentheses 4x squared plus x plus 3. So I'll distribute the 2 to each value in the parentheses. So what I have here is 2 times 4x squared is going to give me 8x squared. 2 times x is 2x. 2 times 3 is 6. So notice how we distribute. I showed the arrows. Here's how the distribution takes place. And then we have that 8x squared plus 2x plus 6, and this will be my final answer for A. B, we're doing something similar like we did for A. We have 3ab in the parentheses 5a squared plus b. So we're going to distribute that 3ab to each situation in the parentheses. So what I get here is 3ab times 5a squared plus 3ab times b. And so when we simplify this out, 3 times 5 is 15. Then we have a to the first, a squared is going to be a to the third, b. Then for the second set we have 3, then we have no a, so it's just 3a. We have 2b, so we add those exponents to get b squared. So my final answer here is 15a to the third times b plus 3ab squared. Here we're going to use the FOIL method. We have 2 binomials, and so we'll use the FOIL method to solve this. Remember, first, outer, inner, last. So multiplying this, we're going to first multiply the first. A times a is a squared. Then we're going to use the outers. So we did the first. Outers is going to be a times negative 4, which is going to be negative 4a. Then we do our inners, 3 times a, which is going to give me 3a. Now my outers, 3 times negative 4 equals negative 12. So then I add all these terms. We have a squared plus negative 4a plus 3a plus negative 12. Are there any like terms here? Negative 4a and 3a, which becomes negative 1a. So my final answer is going to be a squared minus a, or you could have put 1a, plus a negative 12. That's how we solve using the FOIL method. Looking at the next example, we have x minus 3 squared. So what that means is x minus 3 times x minus 3. Using the FOIL method, we'll solve. First is x times x, which gives me x squared. Then we have x times negative 3, which equals negative 3x. Then we do the inners. Negative 3 times x, again, gives me negative 3x. Multiply the last, which is negative 3 times negative 3, which is positive 9. We add x squared plus negative 3x plus negative 3x plus 9. We can combine the negative 3x's to get negative 6x, so we have x squared plus negative 6x plus 9, and that'll be my final answer right there. Here we go. We have this polynomial that we need to multiply, but notice how we have 3 terms for the second set here. So we're going to actually use the rectangle method to help solve this. So the way I'm going to set this up is I'm going to have my x to the third, and then the 4x squared, and then the negative 7. This should actually be here a positive 4, not a negative 4. And so what I'm going to do here is put the 3x plus 1 along this side. So we have 3x times x to the third gives me 3x to the fourth. 3x times 4x squared is going to give me a positive 12x to the third. 3x times negative 7 gives me negative 21x. Then I'm going to multiply 1 times x to the third to get x to the third. 1 times 4x squared is going to give me 4x squared. 1 times negative 7 is negative 7. So then what I'm going to do is I'm going to find my like terms here, and I can combine those. This is actually going to be a positive 12x to the third and a positive 4x squared. So then where I find my like terms is the 12x to the third, x to the third. So my final answer here is going to be 3x to the fourth plus 13x to the third plus 4x squared minus 21x minus 7. We cannot combine any more like terms, even though most of these values, constants, have x's. Notice how they all have different exponents. So this 3x to the fourth plus 13x to the third plus 4x squared minus 21x minus 7, that will be my final answer for example 4 there. That is it for these notes.